Here's a fun program I made in Circuit Playground Express with MakeCode. A little musical instrument. There's a 1-octave range. If I click B, it adds an octave. Another octave. All the way up to 5 octaves. I don't know if you can hear that. All right, let's look at how that works. Here are the instructions. You tilt on the y-axis to change the pitch. You push the A and B buttons to change the number of octaves in the range. So what do we have here? We have a bunch of variables. Oh, this is not used anymore, so let me get rid of that one. Okay, so we set the volume initially to 0 and the maximum number of octaves to 5. The starting pitch is middle C, and the initial number of octaves is 1. And then we call show range, and show range turns on the pixels. Just running here. See how there's 1 pixel on here? Now there are 2. That's coming from calling show range. And then we have to build up the frequencies. We have to know what frequency to use for each of the notes in this range of octaves. And you can do that with a little bit of math. You take your starting frequency and you multiply that by 2 raised to a power, which is some number over 12, and that computes the frequencies. So we go from, so you have max octaves from 0 to 12 times the max octaves. We compute the frequency for that note. This all happens once. Now in the loop, we do this. We have to deal with the fact that you might shake this thing vigorously and go beyond the input range that we're expecting. So this Excel variable gets set to the Y component of acceleration, constrained to at least 0 and no more than 1,000. And these units are, they call them milligravities. And a single gravity is just the effect of gravity pulling on it. Okay, so that gives us the acceleration constrained. And then we find the note that corresponds to that acceleration using this frequencies array that we make here. Now let me switch to JavaScript here for a second. Show it to you there. So we've got this frequencies array of numbers, and then here's that code where we build it up. And then here we find the acceleration, and then we find the note index. So the note index 0 would be the lowest note, a C, and then a 1 would be C sharp, 2 would be D, and so on, all the way up through the octaves. So we get the note index, and then we set the music volume to something such that the higher notes are quieter. Otherwise, because the higher notes really ring out if you don't make the volume vary with the frequency. And then we play the tone. We look up the frequency according to the note index. So if note index is 0, then we play that low C. And then this is the length of time to play. Okay, so back to the blocks, I guess, to see it from that perspective. Okay, so set the volume, play the tone for a quarter beat, and then all that's left is the button click stuff. So let's move these over where we can see them. When you press the A button, then as long as you are still set to be greater than 1 octave, then this will decrease octaves by 1. And then it calls show range, and you remember show range turns on the number of pixels to show the number of octaves that you've got. And then the button B does something similar. Make sure that you are still under the maximum number of octaves, and if you are, then it increases octaves by 1 and then shows the range. So that's it. I'll put a link to the program in the description.